Imagine looking into space and realizing that everything we've believed about the universe might only be part of the story. Just when the James Webb Space Telescope stunned the world with breathtaking cosmic images, another observatory quietly began revealing something even more extraordinary. The Euclid Space Telescope is sending back images so incredibly detailed that astronomers are discovering enormous hidden structures, mysterious patterns, and invisible forces shaping the universe on a scale never seen before. These aren't just beautiful photographs. They're exposing a cosmic web that challenges our understanding of how galaxies formed and what truly holds the universe together. Some scientists have even admitted that the first results were far more surprising than they expected. But before we dive in, if you love exploring the greatest mysteries of space and the universe, make sure to subscribe and turn on notifications. We're on the road to 1,000 subscribers, and your support helps us bring you more incredible discoveries every week. In today's video, we'll break down Euclid's most astonishing discoveries, uncover the science behind these incredible images, and explore why many researchers believe we're entering a completely new era of astronomy. Make sure you stay until the very end, because what Euclid is preparing to reveal next could change our understanding of the cosmos forever. Euclid is not a normal space telescope. It was never designed to focus on a single nebula or zoom in on one spectacular galaxy. Its real mission is far more ambitious and far more unsettling. Imagine launching a telescope with a mission so ambitious that it isn't meant to study just one galaxy or one corner of space, but the entire universe itself. That is exactly what happened in July 2023, when the European Space Agency sent the Euclid Space Telescope on its extraordinary journey. Instead of orbiting Earth, Euclid traveled nearly 1.5 million kilometers away to a quiet location known as Lagrange Point 2, where the Sun, Earth, and Moon would never interfere with its view. From that distant outpost, it began staring into the deepest reaches of the cosmos, with a goal unlike anything attempted before: to create the largest and most detailed map of the universe ever made. Unlike most space telescopes that focus on tiny sections of the sky, Euclid sees the universe from a much wider perspective. Its enormous field of view allows it to capture vast regions of space in a single image while still preserving incredible detail. Imagine standing on a mountain and being able to see every city, every road, and every house on the horizon without losing clarity. That is essentially what Euclid is doing with galaxies. It can observe individual galaxies with astonishing precision while simultaneously revealing how millions of them connect together to form gigantic cosmic structures stretching across unimaginable distances. But this is where the story becomes far more mysterious. Euclid isn't simply photographing stars and galaxies. Hidden behind every image is another invisible picture, one that no human eye has ever been able to see directly. By measuring tiny distortions in the shapes of distant galaxies caused by gravitational lensing, the telescope is exposing the influence of dark matter itself. It is as if the visible universe is only the skin, while Euclid is revealing the hidden skeleton beneath it. That invisible framework shapes everything around us, yet no one truly knows what it is made of. Then came the moment that left scientists speechless. Euclid transmitted its very first giant mosaic of the southern sky back to Earth. At first glance, the image looked beautiful, but as researchers zoomed in, they realized they weren't looking at an ordinary photograph. During only a short observing session, Euclid had captured 260 separate images covering an area of space nearly 500 times larger than the full moon. Once stitched together, those images revealed millions of stars and galaxies in astonishing detail. And perhaps the most astonishing part was realizing that this breathtaking view represents only about 1% of Euclid's entire mission. What scientists are studying today is not the finished map. It is only the first tiny piece of an unimaginably larger puzzle. From one moment, they can examine gigantic structures spanning millions of light years, and with the next zoom they can study individual galaxies without sacrificing detail. It is giving humanity its very first preview of what will eventually become the most detailed three-dimensional map of the universe ever created. Among Euclid's earliest discoveries, one image immediately captured the attention of astronomers around the world. It focused on the Perseus cluster, located roughly 240 million light-years from Earth. At first, researchers counted more than 1,000 familiar galaxies, along with over 100,000 distant galaxies shining faintly in the background. It already looked extraordinary. But the real surprise appeared only after scientists examined the image more carefully. Hidden within the cluster were more than 630 dwarf galaxies that had never been seen before. These tiny galaxies were so faint that every previous telescope had overlooked them completely. For decades they had remained invisible, quietly hiding among much brighter objects. Euclid uncovered them in a single observation. That discovery was far more important than it first appeared. Dwarf galaxies are especially sensitive to the pull of dark matter. Their shapes, movements, and locations behave almost like tiny fingerprints, revealing where invisible mass is concentrated. The discovery of hundreds of previously unknown dwarf galaxies suggested something remarkable. Dark matter may not simply surround galaxies. It may shape them in ways scientists never fully appreciated. The evidence increasingly points toward a universe that is not merely filled with dark matter, but fundamentally built upon it. As researchers continued exploring Euclid's observations, they found surprises everywhere they looked. Inside the nearby galaxy NGC 6822, the telescope detected ancient low-metallicity stars whose chemical composition closely resembles the earliest generations of stars formed after the Big Bang. It was like opening a time capsule from the young universe, offering clues about how galaxies evolved billions of years ago. Elsewhere, inside the ancient globular cluster NGC 6397, Euclid resolved faint stars hiding along the cluster's outer edges. For years, those stars had remained invisible because the brighter central stars overwhelmed them. Now, astronomers could finally study these forgotten populations and uncover new chapters in the history of our own Milky Way. Perhaps even more surprising was what Euclid found inside the famous Horsehead Nebula. Beyond the clouds of glowing gas, its extraordinary sensitivity detected evidence of free-floating planets and Jupiter-sized worlds wandering through space without orbiting any star. These lonely rogue planets may be far more common than anyone had ever imagined, hinting that our galaxy could contain countless worlds drifting through darkness completely alone. Together, these discoveries reveal something unexpected. The universe is not quiet or orderly. It is alive with constant motion, hidden interactions, and invisible forces shaping everything from tiny stars to enormous galaxy clusters. As more observations arrived, another astonishing pattern began to emerge. Galaxies were not scattered randomly across space as they might appear from Earth. Instead, they were woven together into enormous filaments stretching across hundreds of millions of light years. These gigantic cosmic threads intersect at massive junctions where entire galaxy clusters are born. When viewed through Euclid's eyes, the universe begins to resemble an immense neural network rather than an empty expanse of space. Matter appears to flow along invisible highways constructed almost entirely by dark matter. These filaments are no longer theoretical predictions hidden inside computer simulations. Euclid allows scientists to see their influence directly in the way galaxies bend, stretch, and align across the cosmos. What makes this discovery truly unsettling is not simply that these invisible structures exist, it is their overwhelming scale. Every galaxy, every cluster, every enormous cosmic void, including the Milky Way itself, exists within this gigantic web, guided by forces that humanity still cannot directly observe or fully explain. One of Euclid's greatest strengths is its remarkable ability to detect gravitational lensing with extraordinary precision. By measuring incredibly tiny distortions in the shapes of distant galaxies, the telescope can effectively reveal where dark matter is hiding. These distortions are almost impossible to notice individually. But when millions of galaxies are analyzed together, an invisible map slowly emerges. That hidden map reveals enormous concentrations of dark matter bending space itself and warping the light traveling through the universe. The truly unsettling fact is that these colossal structures emit no light, reflect no light, and remain completely invisible. Yet together, they outweigh every star, every planet, every galaxy, and every cloud of gas that we can actually see. In many ways, Euclid is introducing us to a universe where the dominant form of matter is something humanity cannot touch, detect directly, or even identify with certainty. And yet, this invisible substance quietly governs the motion, growth, and ultimate fate of entire galaxies. Euclid also allows us to travel backward through time. Some of the galaxies captured in its earliest images lie more than 10 billion light-years away. Their light began its journey long before our solar system even existed, carrying with it a snapshot of a much younger universe. Because Euclid can observe ancient galaxies and nearby galaxies within the same field of view, astronomers can reconstruct how the cosmic web evolved across billions of years. But the results are already challenging long-standing theories. Evidence suggests that massive structures formed earlier than expected. Galaxies assembled faster. Dark matter organized itself sooner. The universe appears to have matured far more rapidly than many existing models predicted. If these conclusions continue to hold, scientists may need to rethink not only how galaxies formed, but also whether our current understanding of gravity itself tells the complete story. And considering these discoveries come from only the earliest fraction of Euclid's mission, many researchers believe the telescope's greatest revelations are still waiting to be uncovered. Now comes the part that may be the hardest to believe. Everything you've heard so far, every breathtaking image, every hidden galaxy, every invisible structure, every discovery challenging modern astronomy, comes from just 1% of Euclid's planned mission. That's right. 99% of its cosmic map hasn't even been created yet. For the next 5.5 years, Euclid will continue quietly scanning the heavens, section by section, filling in enormous blank spaces, sharpening details that have never been seen before, and uncovering patterns scientists don't even know to search for yet. And if only 1% of its observations has already begun rewriting our understanding of the universe, imagine what the remaining 99% could reveal. The complete picture may be far stranger than anything we've ever imagined. But Euclid isn't simply taking beautiful photographs of space. Every image it captures becomes part of an enormous scientific archive, one of the largest collections of astronomical data ever assembled. This growing database is so detailed that many researchers believe it could force a complete rethinking of modern cosmology. Questions about dark matter, dark energy, and even the expansion of the universe itself may soon have entirely different answers. Then researchers noticed something even more unsettling. The greatest discoveries weren't always hiding where galaxies existed. Sometimes They were hiding where galaxies didn't exist at all. Scattered across the universe are unimaginably vast regions known as cosmic voids. At first glance, they appear almost completely empty, stretching across hundreds of millions of light-years like giant holes carved into the fabric of space. But Euclid revealed that these regions are far from meaningless. They possess shape, boundaries, and structure, all carefully sculpted by the same invisible forces responsible for building massive galaxy clusters. As astronomers examined these enormous voids more closely, another mystery emerged. The galaxies surrounding them appear to be moving in ways that suggest dark energy is actively driving matter away, causing space itself to expand even faster. Instead of looking like empty gaps, these voids resemble enormous pressure zones where the universe is literally being pulled apart. It raises an unsettling possibility. The cosmos isn't simply expanding on its own. It may be constantly reshaping itself through forces we still barely understand. That possibility is exactly why Euclid was built. Its mission extends far beyond mapping galaxies. It was designed to hunt for dark energy, the mysterious force believed to be accelerating the expansion of the universe. By measuring the positions and redshifts of billions of galaxies with extraordinary precision, Euclid can reconstruct how cosmic expansion has changed throughout billions of years of history. And the first results are already raising eyebrows. Early analyses revealed tiny deviations from what current theories predict. Individually, these differences seem insignificant, but together they form a pattern that refuses to disappear. If future observations confirm these findings, scientists may have to abandon the long-held assumption that dark energy remains constant over time. Instead, it may be evolving, changing its behavior as the universe grows older. Such a discovery would transform our understanding of cosmic history and force physicists to rethink one of the universe's greatest mysteries. Yet another challenge is beginning to emerge, one no telescope has ever created before. The sheer amount of information Euclid is collecting is almost impossible to comprehend. Humanity is no longer studying thousands or even millions of celestial objects. We are now dealing with billions of galaxies mapped across three-dimensional space and billions of years of cosmic history. No human mind can fully visualize patterns on that scale. To understand its discoveries, astronomers are increasingly relying on artificial intelligence and advanced algorithms capable of detecting relationships hidden inside unimaginable amounts of data. In a strange twist, machines are now helping humans understand observations made by another machine. The unsettling reality is that some truths about our universe may simply be too enormous for human intuition alone to recognize. Perhaps that's the deepest lesson Euclid has offered so far. Its discoveries aren't simply revealing new objects in space. They are exposing the limits of our own understanding. Dark matter, dark energy, gravitational lensing, accelerated expansion. Together, these invisible phenomena control almost everything that happens across the cosmos. Yet scientists still cannot explain what most of them actually are. Euclid maps their fingerprints with extraordinary precision, but the true nature of the forces behind those fingerprints remains hidden. In many ways, the telescope isn't just revealing the universe. It's revealing how much of the universe we still don't understand. And that's exactly what makes its images so haunting. At first glance, they seem peaceful. Spiral galaxies shine elegantly. Nebulae glow with vibrant colors. Dense star clusters sparkle like jewels scattered across the darkness. But spend enough time looking, and that beauty begins to feel different. Every perfectly curved filament, every delicate gravitational distortion, every precisely arranged galaxy exists because invisible forces have been shaping the cosmos for billions of years without ever stopping. Gravity never rests. Dark matter never releases its grip. Space itself never stops expanding. What appears beautiful is actually evidence of relentless cosmic machinery operating with perfect precision across unimaginable distances. Euclid's observations also reinforce a profoundly unsettling truth. Galaxies are not the true architects of the universe. They are merely the visible decoration. Long before stars ignited, enormous halos of invisible dark matter collapsed under gravity, forming the hidden scaffolding upon which galaxies would eventually appear. Only after that invisible framework already existed did stars begin to light up the universe. Euclid makes this invisible hierarchy impossible to ignore. Everything we can actually see is simply resting upon something we cannot. Perhaps one of the most astonishing things Euclid accomplishes is allowing scientists to observe different moments in cosmic history all at once. Within a single image, nearby galaxies appear exactly as they exist today, while distant galaxies reveal themselves as they looked billions of years ago. Even older structures preserve snapshots from shortly after the universe itself was born. Past and present exist together inside the same photograph. That means Euclid is doing far more than imaging space. It is recording history itself. By comparing galaxies at different distances, astronomers can literally watch the evolution of the universe unfold across billions of years. And perhaps that's the most humbling realization of all. The moment we call now is only an instant within a story that began billions of years before Earth ever formed, and one that will continue unfolding billions of years after humanity is gone. As Euclid continues its 6-year mission, scientists are beginning to realize its greatest discoveries may be the ones no one expected. Built to study dark matter and dark energy, the telescope is already uncovering mysterious patterns that challenge everything we thought we knew about the universe. With every new image, one truth becomes impossible to ignore. The cosmos is far stranger than our current theories can explain. Euclid is showing us that most of reality is invisible. Dark matter quietly shapes galaxies. Dark energy drives the expansion of space, and the forces controlling the universe remain largely unknown. The breathtaking images are more than beautiful. They are reminders of how little we truly understand. And this is only the beginning. Euclid has mapped just 1% of the sky. If these first discoveries are already rewriting modern astronomy, imagine what the remaining 99% will reveal. The universe hasn't changed. We're simply seeing it clearly for the very first time. If you enjoyed this journey, don't forget to subscribe. Leave your thoughts in the comments and join us as we explore the next great mystery of the cosmos.